All right, hello students. In this video, we're going to learn how to graph rational equations, and we're going to focus our efforts on the parent graph of rational functions, which is 1 over x. F of x equals 1 over x. And the first thing we want to do is, what does f of x equal 1 over x look like? So I'm going to use the graphing calculator. See if I can turn it on. There we go. I'm going to go to y equals, and plot in 1 divided by x. Sorry, I had to cough there. And this is what it looks like. And it looks like it's approaching this value, and it's actually never going to cross. And it's going to approach this value. So let me get a different color. And what we have are what are known as asymptotes. And I'm supposed to be sketching this right on the axes, but this is known as a vertical asymptote. And we also have a horizontal asymptote. And a horizontal asymptote is a line that the function approaches but never reaches it, and never crosses it. All right, and with a different color, I'm going to sketch the curve. And what I normally do is I kind of put my point here, and I do this. It's kind of hard with this digital pen. Here we go. See? And this is why what 1 over x looks like. This is like the original curve. All of the curves are going to be based off of this one. So what would be the domain? What would be the values of x? Well, x can be anything except 0, because if you look, the curve never really crosses this point. It exists to the right of 0, to the left of 0, but it doesn't exist at 0. So the domain of this function is going to be, we can say all reals except all reals, but x can't be 0. Right? So x can be anything but 0, because the function doesn't really exist at 0. It exists to the left, to the right, or to the left, but not at 0. How about the range? Now we're looking at the y values. Well, it looks like y can be anything going down, anything going up, but you see how the function is never really at 0 on the horizontal asymptote either? So we say that for the range, y can be anything, y can be any real number, but y can't be 0. All right, for a vertical asymptote, where does the vertical asymptote exist? Well, the vertical asymptote exists when x equals 0. Right? That's what this line is, when the value of 0, when x is 0. What about the horizontal asymptote? Well, the horizontal asymptote is the y-axis, right? Well, the y-axis is y equals 0. All y values here are 0. So we would say that the horizontal asymptote occurs at y equals 0. Do we have an x-intercept? Well, this function does not cross the x-axis. See, there's no blue. In fact, the horizontal asymptote is the x-axis. So the function doesn't cross it. So for this one, we say none. Do we have a y-intercept? No, it never crosses the y-axis, because the y-axis happens to be a vertical asymptote. So for this one, we would say none. This is not going to be the case. This is the information for the parent graph. What about the end behavior? Well, let's look at this. As x goes to positive infinity, so as x is getting bigger and bigger, what's the value of the function approaching? Well, here it's around 1, 1.5, and it's getting smaller and smaller. The y value is getting closer and closer to 0. So as x is getting bigger and bigger, the function is approaching a value of 0. Now let's look at over here. As x is getting bigger and bigger, the function is approaching what value? 0 as well. Or the horizontal asymptote, right? So as the function goes to positive infinity, it approaches the horizontal asymptote. And as x goes to negative infinity, the function also approaches this horizontal asymptote. Where is the function increasing? Well, actually, this function is not increasing. If you look at it, let me see if I can get a different brush for this. You look right here and you start from here. What is, oh, this is a bad color. You always start from here, and then what is the function doing? It's going down. So, and then over here as well, it starts here, but then what does the function start to do? It starts to go down. So there are no intervals of increase, but we do have intervals of increase. So from negative infinity all the way up to x equals 0, but 0 is not included, right? Function's decreasing. And from 0 to positive infinity, the function is decreasing.